every single week we have the AWS Machine Learning Zero to Hero event. That said, instead of us having like the talk style or meetup style or conference style where each speaker or member or basically a machine learning hero would be sharing a 30-minute talk or something, we have been alternating it between 30-minute talks or a panel discussion or one-on-one interviews. So probably over the next 2 months or 3 months, we might have to do one-on-one interview with Cyrus on a specific topic or a one-on-one interview with Rustem. So right now it's just a panel discussion with both of them as the panelists. So when we do a one-on-one interview in the future, it will have a different set of questions. So for the next, so basically, if you want to know more about them, and if you want to know more about us, just look for, just try to search AWS Machine Learning Heroes. So even if you're in different parts of the world, these guys are famous in their countries, especially in their countries. And if you want to reach out to them, go for it. They're probably they can probably reply to you via LinkedIn or via email or something. They can share with that to you later. But basically, over the next couple of weeks, yeah. So I just happened to put September 5 there. But basically, the next couple of events would be, so next week we have a series of talks by Or, and I'll also do a talk on machine learning with Or and SageMaker. And then I have a one-on-one interview with Or on August 29 and with Augustinus on August 29 as well. And on September 5, we have a panel discussion with Lyndon and Thomas. So most likely the topics there would be on Deep Razor. And I guess basically the machine learning concepts on how that thing works. On September 12th, we'll have Rustem talk about AWS Step Functions, SageMaker, AWS Batch, and Fargate to organize deep learning pipelines. So stay tuned for that. And then we'll have Augustinus talk about building a bot that plays videos for my toddler on September 12th. So on September 19, we have invited Julian Simon, the AWS evangelist, for a one-on-one interview or a talk. So we're just waiting for his topic, but he has agreed to share his ideas and experience on September 19. So if you try to search for Julian, you'll see some of his videos on SageMaker and how to deploy these things in different manners, which are usually hard to find in documentation. So you probably know Julian if you're looking at the AWS stuff. And we also have Matthew Fryer talking about creating and scaling AI and enterprises. So yeah, so we have planned out the next 2 to 3 months. Yeah. So for today, the topic will be about machine learning engineering, tips and tricks, tips on how to get different people get started to machine learning. We also want you guys to share your experiences and also your the things that you feel would be which might be new to some people. So probably advice, tips, and also misconceptions, things that will go on trend for the next couple of years. And you can also share here some amazing machine learning projects that people can check. And probably also some advice. Let's say that you want to give advice on if people want to join Kaggle events, for example, and getting them trained up, or if there are also other references, we can also discuss those things bit by bit. So this is going to be on our panel discussion, and then we'll go around the room, quote unquote room, first with Cyrus, and then Rustem, and then Cyrus, and then we'll give you guys each, let's say, 3 to 5 minutes, or even 10 if you want, just to talk about a certain topic of the during this session. Yeah. So I guess first question. So the first question is for Cyrus and Rustem. Introduce yourself in, let's say, 3 to 5 sentences. How you got to machine learning, and basically your story for the past 3 to 5 years, for example, it would be great for the audience to know who you are and what you do in your day jobs.
Okay, sure. Maybe you just can start, huh?
Sorry?
I can start. Yeah. Yes, share. Yeah, for the my background. Okay. Is this okay? Yeah, actually, I'm in Hong Kong, and I'm actually I actually am a lecturer in the technical college to teach students mainly. But for myself, is maybe I'm not always building model, but I will try to I will have a lot of project on building chat block, using the high level AWS managed AI API, and sometimes I will use some pre-built model and minor modification to build different projects. And somehow before that, maybe a few years ago, we are so-called I'm more like a data scientist than a machine learning guys. But this is something very, very similar. As the maybe we can discuss more later. As somehow at this moment, a few years ago, is very, very popular. They're talking about data science, and I'm working on something more data scientist before. But now we are talking about machine learning, and as I somehow I migrate my knowledge from data scientist to more like a machine learning. But due to I'm always using AWS, and I will try to work with the high level API to build my application, especially on educational domain or some related to school and something like that, since I am working some applied educational project in general. I have been the AWS community hero a few years ago, since 2060. Okay, but before, once the machine learning hero categories run out, I switched from the community one to the machine learning one. Okay, that's my background. Okay, thanks.
Great. Rustem.
Okay. Hi everyone, I'm Rustem. I'm machine learning engineer at Instrumental. So basically, I would say that I'm more on the engineering side of things. So basically, I kind of like started working with AWS first when I started looking into how to use like serverless infrastructure. And then I just started like porting different libraries for AWS Lambda, made a repo with it, and like I wanted to kind of learn, is it possible to port like machine learning, deep learning libraries and frameworks to serverless? Because basically one thing which I liked about serverless that you can start like very easy, and you don't need to maintain server. So basically for me at that time, it was the easiest way to deploy some machine learning or deep learning model. But then I understood that not only that, like there could be a lot of other advantages. So that's why basically I started like maintaining repos, making online courses about basically how to utilize serverless infrastructure for deep learning and machine learning projects.
Great. All right. So my first question is, actually my second question is, so thank you for that. My second question is, in 3 to 5 sentences or more, or maybe 7 or 10, can you describe or define what machine learning is? Yeah. So given that the topic is machine learning, it would be best to describe what machine learning is or what statistical learning is. Yeah. So Cyrus or Rustem, feel free to go ahead and answer that. Yeah.
Okay.
So
maybe let me go first. Yeah, from myself, is actually I think it's something quite similar. Is in a very long term ago. In the past, we will sometime when I study before I studied the master degree, and I studied something like statistics and quantitative analysis. At that time, the terms is sometimes due to the computation limitation. In the past, we will always talking about statistics, but in statistics, well, it's a lot of model building. But with time go by from the more powerful computer, the big data technology coming out, it's become the statistic to the population wise to analyze all the data to get out the pattern. For machine learning, actually, is something very quite similar in the past talking about. We are in the way where data have some pattern, and machine learning is learn from the data to learn out the pattern, and then use the model existing pattern to do some automation activity, prediction, something smart according to the previous data. This is somehow is supervised as well. This is called supervised learning. Is machine learning in the past is statistical and something like math, but now due to the computational power is much better, and also the GPU, we can even the history of machine learning say about neural networks many years ago, but at that time there is not enough computation equipment or processing power. We are just a theory, but now is everything we can calculate, and then machine learning is just mainly the machine learning is something like teaching the machine to use the data to let the machine learn the pattern and then do something for you. And maybe this is my my feeling on machine learning. Okay.
Great, Rustem. How about you?
Yeah, well, I would say maybe I just want to add like one like high level term, like in a way that basically in certain way, like it's just two different ways of solving things. And basically if they like, there are deterministic ways of doing it, like writing code with like if else and like so on. Basically when you know, like for example, when you want to make a scoring algorithm to define like whether you want to give credits or not, you could do it deterministically. So, but the main part is like fundamentally is that you don't write logic yourself. You just like create some architecture and pass data. And then based on this data, now you get model which will work in production. And basically this fundamental change in architecture kind of changes the whole thing, how it works in production. So basically, if you could like write code and supply it with unit tests, and it would work like for a long period of time, like machine learning, deep learning models could become obsolete like very fast. For example, like recently when a lot of patterns changed into how people behave due to COVID, a lot of models became like unusable. And that's basically the main challenge. Like there are a lot of challenges which come with this kind of approach, that you have to always retrain your model. You have to always gather a lot of data, and basically, and you need to have like a way to test whether your new model performs better or worse, because like it's not like obvious that your new model will perform better. So I would say, but at the same time, so there are a lot of challenges, but at the same time, with this approach, due to like how many computation powers do we have today and how many data do we have, basically it's a lot easier to create machine learning, deep learning models for problems that before like were very hard to solve, like everything connected with visual data, with images, video, with audio data, with text. Basically, it's completely changed like how we process it. And I think it's like on one hand, like it's like deep learning cases, and on another hand, there are machine learning cases with like even like table data where they already can perform pretty good, and you can just like get more insights from even table data for different applications. And I think from this perspective, machine learning, deep learning become more like something which is used by a lot of companies. Sometimes they use it as an outside source. Sometimes it's something which they have to develop within themselves, but it's something which becomes like natural for a lot of companies and for a lot of applications.
Great. Those are really good answers. And while we're at it, I think it's also best if we define what deep learning is. Yeah, so go ahead. Let's define what deep learning is. So, and maybe other concepts as well revolving that topic. Yeah, like neural networks and so on. So who wants to go first?
Maybe again for me first. Yeah.
Sure.
But just actually I think it's somehow from the researcher point of view is it's talking about in general we will simplify it. It's talking about we are talking deep learning is most likely related to neural network. Okay, but sometimes we would define how many layer we will classify, how many layer will become the normal machine learning and then become deep learning in some of the definition and guy will think about it. You got a more layer and more neuron, and it will become the very non-linear curve fitting. Yeah, actually for the single neuron case, it is just a logistic regression. It is very classical statistical modeling. But due to you got more, you can make your curve more interesting. You can say a circle with a higher dimension, and actually the most powerful the deep learning concept is the convolution. Before that, we don't have the convolution idea. With the convolution idea, we will somehow talking about deep learning, and I think it's mainly related to the more layer and more concept on the convolution or different neural network technique. Yeah, this is about deep learning for something very complicated problem. We process but in the past, to be honest, in the past, there's something like signal processing. We are talking about convolution is from the past before we're talking deep learning. I study electrical engineering. We're talking about signal processing, how to handle the signal. It is quite similar concept in the very complicated signal. It is image-like signals, noise is signal. But now we are talking about using neural network. It's something, this is related to the development of using GPU. In the past, we don't have the general purpose GPU to do the major calculation effectively. Now we something we deal with complex neural network and have many layer, many convolution with GPU. This is maybe this is a classification into deep learning. Yeah. Okay. But you stop here.
Great. How about you, Rustem?
Yeah, so I think Cyrus covered everything pretty well. So I would just add that, like, on high level, like, the whole thing is machine learning basically in a way that we supply data and want to get model which will make any predictions or inferences. The difference with deep learning is basically like some machine learning algorithms expects to already have some features which could be used, like, and they expect these features to be pretty high level. That's why, for example, they can work with table data, but they just can't work with like images or text, because like images or text, like at one hand, like it's the same data as, like, let's say, like any table data, like age or like income or so on. But at the same time, it's pretty raw in a way that, like, you need to have some additional way of extracting high level features, understanding like text meaning, understanding objects on the picture. And that's where like deep learning works best, is basically transforming raw features or raw data into more high level features. And basically deep learning operates like by using multiple layers networks, neural networks. And the way it works is that basically it tries to extract more and more complex features on each layer, and by the end of it, it will have like high level features. And basically you can transform just having a picture into having like what's the possibility of the picture being like cat, dog, and so on. And then you can, for example, put some machine learning model which would like specifically solve your business solution if, for example, you need to make a camera which would distinguish between cats and dogs.
Great. Yeah, really great answers for the what's deep learning and what's neural nets and so on. Yeah, so I think for some of the attendees, what they probably want would be a couple of examples. So feel free to share as many as you can on some of the things that machine learning has solved for us. Some of the more practical things that machine learning has solved for us. At the same time, if you know some of the newer like quote unquote inventions, or let's say some of the new techniques that we have learned this past couple of years and we have applied in different fields, feel free to share them too. So basically the question or the topic would be, what are the examples of the problems that machine learning can solve for us, especially for the past 5 to 10 years. Yeah, so go for it. Examples. Yeah, Cyrus, Rustem. You guys there?
Yes.
Yeah. Maybe Western's first.
Okay, yeah. I can start with basically, well, yeah, you're raising probably on my previous answer that basically everything connected with visual data, images and videos, and everything connected with text. And I think like a point of 2 years ago, it was like that just it was just a concept of using something like WordVec when we could like understand the meaning of words and like put vector on it. But now, and it became a lot more complicated, like with GPT-3, it's like now we can generate texts. Now we can basically understand, like we can classify paragraphs of text into like, and use it basically as a kind of this both feature extractor, but also as a way to generate new text. And I think like that's the main trend, like that. I think in the beginning you could only use it like for some supervised problem, but now you can even use it like for generating some new data out of like even like new text or new images or new audio. And
Yeah.
I think that's the kind of like big new
Yeah,
trend
I think
here.
agree. It's actually to be more funny is that we are talking in the past we are talking about the machine learning is say the supervisors you feed the data have the target variable and then we move the focus from more supervised to unsupervised algorithm. And but now we are also have the reinforcement learning category is much popular in the recent year. For interesting cases, the deep razor, deep composer, they are talking about not just this is not from learn. This is not you are, for example, for the deep razor cases, you are unable to prepare the whole well data to the automated car. You need to you're unable to do it. That is how the AWS do it is it's just they use a reinforcement learning in the virtual world to fit some mock data and then it is not learning the is not remember. In the past, I can say that machine learning before that we are somehow is statistics that more like statistical well. We are trying to use the old data, let them to remember. Okay, the model is remember something, and then you fit the new data. There's such recall. Yeah, there's something like recall the pattern, and then it look like which record. This is in the past. The machine learning is learn something from the old data to get the pattern, and then give some feedback which one is more similar. But now the machine learning is the model is much more powerful. Is that you just give them some data there, and then try to get the feedback. Is it good or bad? Good or bad? Is it learns? It create a model able to generate new information. Yeah. For example, for the deep razor, is it generate the action, the new action for the car, even though the road condition is never appear, learn again. Yeah, you know, in the well is unable to get all the car info, car photo and video for whole of the well. It just have some simple learn the skill. For the deep composer is another funny. You just use two neural network. One neural network is generate a song, another neural network is rating it. How good is the song, and then let it like a circle, learn it, test it, use two neural network to handle this kind of problem. This is much more in another trend is value add or information add extra information to the from the input, not just classify something. Yeah.
Great. So actually there are a lot of like things that has been changing a lot. Even in our phones, you can see that sometimes you can see some subtle things that machine learning has like improved for us. I have also seen some images which were enhanced using machine learning. So those are pretty cool things. And same way as with the things you mentioned, machine learning has actually started even a long time ago. But right now, given that there are a lot of like frameworks, libraries, and tooling to help us do our machine learning projects, those have certainly increased the velocity of a lot of projects involving like machine learning and machine learning engineering. So from your guys' end, my question is, I realized my video wasn't turned on, but yeah, I've turned on the videos that were all the same. My question is, what's your favorite machine learning framework and basically the tools or even a service? So we can talk about one or two of your favorite machine learning frameworks or services. So let's say SageMaker, or maybe TensorFlow, or Apache MXNet, PyTorch, and so on. And can you share your experience with it and why you would recommend it to people around you? Yeah. So who wants to go first on machine learning framework, services, or tooling? So it can be an AI service in AWS, or yeah. So even let's say, yeah, go Cyrus.
Okay. In the past, I will think about build the model first, but now is if I have a choice, I will try to use the high level API service from Cloud Vendor, or will try to use it. As this is difficult and time consuming if you just do something they have done something very similar. First of all, the first layer of the model is called the API, and then we have the first level classification, and then if it is not enough for my application, I will just build another layer of simplify the model. It's more easier to handle it. But for the tools I'm using, I'm not always building the model myself, but just if the data is, if it depends on you are doing something deep learning or not. I'm not always doing the deep learning model. It is not necessary for my business application. It's especially not everything need deep learning. Okay, especially for the data is in tabular and database and historic record, and you use the classical machine learning model, it will take you less time. And also it's some experience from the user or the management. The management will sometimes say that you need to explain to me what's happening to your model. The main problem of using neural network for the business well is that if you need to explain your model or have some data analytic requirement, you can't explain the neural network model easily to the user, and they will think about what is this, and also if it is not the data related to image or saw or something like that, we can use a classical one. The text, video, image will need to use deep learning. But for myself, so that's the reason why I am a RO user. If I can use something on RO, I will just use RO to handle it, and it's quite straightforward. Just load the data there and then use RO to build a decision tree, to build something. It's very correct for the business. For my case, it's for the educational, for the research, for business. I just want a powerful, easy to instance to build our model. It's quite fast and straightforward and it's traditional way. That's the reason why you talk about framework. I'm not always using deep learning framework, but if I need to use, I will use PyTorch or something like that. It's quite easy to start and just fit the data in. Yeah.
Great. Thank you for that, Cyrus. How about you, Rustem?
Yeah, I would add on top of it that basically, yeah, frameworks like TensorFlow and PyTorch, they basically democratize deep learning a lot because they're open source. You can freely download them and use them. And I would say you don't need GPU to start, and basically you can just run it on any laptop. And I think with recent updates to both TensorFlow and PyTorch, they became somewhat similar in terms of it's a lot easier to define a neural network compared to how it was like several years ago. And I think there are a lot of like documentation and a lot of examples how to start. And it's really a lot easier to start, I would say, right now. I think there is a certain but once you play with different I would say, frameworks and different like model architectures, that's where like it's could be hard to kind of use it in production. And that's where like some AWS services could be really convenient in terms of organizing production workflow, because basically having production for machine learning or deep learning is like somewhat a very different story, where you want it to be part of your like of your existing production, and you want to have like an automatic way of training the models and do a lot of stuff. And I think I like recent developments of with SageMaker and Amazon SageMaker, basically because like I would say SageMaker that isn't like a one service, but more like a family of different services. And I think it includes a lot of things which are pretty good. So basically the way you can just deploy Jupyter Notebook but with one click, and you don't need to handle like authentication. It will work out of the box. It's labeling tools. It's tools for basically automatically train pre-existing model or train your own container, and and deploy inference endpoint. And basically this whole pipeline kind of you can use for different parts of your projects.
Great. Yeah. Actually interesting part there regarding SageMaker. Because SageMaker is the machine learning service of AWS right now. There are a lot of features there, and definitely it has made a lot of things easier. And in the past, you had to build some of those things yourselves. So even from my end, when I saw SageMaker, it's like, oh, you try to perform the first couple of steps in SageMaker. In a SageMaker notebook, for example, use the SageMaker APIs, and then with 1 line or 2 lines of code out of nowhere, ta-da, you have your endpoint. Yeah. So 2 to 3 years ago or 4 years ago, can you guys still remember how it feels or how it looks like to do machine learning in the cloud, or maybe in your local machines, for example? So when you guys were playing with machine learning stuff years ago, so how does it look like before, 4 years ago, 3 to 4 years ago, or 5 years ago? And now how does it look like now?
Yeah. In the past, I remember I have to set up a cluster. Yeah. Before the cloud computing, because I'm using Amazon, I need to set up a set of computer in my lab, and then form a Hadoop cluster and run the machine learning model there. Yeah. And then we migrate to using RO, and the problem is that in the past we don't have it is quite nice to have the hyperparameter optimization. In the past, you just do something by guess, and manually you think about, what's the parameter to tune it. This is something like try and error, and very difficult to make sure my model is the best one, or the can't say best one. Is it always can find a best one in the past? You feel always tuning, sometimes good, sometimes bad. But now is from now into the cloud, well, it is very nice to have it's something like, to be honest, the machine learning is just like using a lot of computational power to find out an answer, or the minimal the errors or something like that. You have more computer to run it in parallel to find an answer faster. And this is something really very nice. Is the hyperparameter tuning, autopilot. It is something quite breakthrough, as the part is something quite, you are not sure how to tune it, but now Amazon can help you, or you don't have to think about the variable. You just give it a range, and then it will try to use the experience to build on top of the model, find out the optimized solution for you. It's quite different. In the past, you take a lot of time to set up the architecture. For myself, I do remember I have 10 computers together to solve a problem on clustering, on building model with Hadoop. But now it is quite straightforward. We just maybe the migration part from on-premise Hadoop to the EMR, and then now is SageMaker. It's much easier, and and save the time. To be honest, I want to have the model. I don't want to set the server. To set the server is quite painful. Yeah, and sometimes the data got crashed in one of the two servers. It can't recover. Now it's much happier. Everything on S3. Yeah.
Yeah. Completely agree with that. How about you, Rustem?
Yeah, I had pretty similar problems. So I would say there are like two main things which were pretty hard, like 3 or 4 years ago. So one is basically if you want to set up any, like, for example, basically something like Jupyter Notebook is the core of running experiments. And it used to be, well, it's somewhat sometimes like hard now also, but like setting Jupyter Notebook on the instance and making sure that basically it's not open to the world. So that's a paradox that basically you want to be able to open your Jupyter Notebook, but at the same time, you don't want other people like outside of your team to be able to open it. So you have to install SSL certificate. But since if you don't have a custom domain, then you can't actually like have trusted like a SSL certificate. So you will have a self-signed one. And then when you open it every time, your browser will tell that it's untrusted. This is an untrusted certificate. So that was pretty annoying. And I think that's changed because now there are a lot more hosted Jupyter Notebooks services, and that really helped a lot. And I would say second thing is running experiments. So now there are a lot of good frameworks like MLflow or DVC, which heavily help to record all small details of your experiments, like including metrics, including some artifacts like your data, which was used for training, or model which you trained. But it used to be that you had to manually implement all of it, basically, how you save metrics, how you save model, and a lot of these like things which are not directly connected with your work, but you still have to do it because you cannot run experiment if you cannot save the results, and if you cannot compare like results between each other, then it's very hard like to try different architectures, because at some point you will just like lose sight like which experiments you already run and so on. So I think like in this perspective, there are a lot of services which significantly improved the like handling of experiments and saving experiments results.
Great, thank you for that. So while we are in that topic, let's talk about machine learning engineering further. So basically, the first thing that I would like to ask you guys, because I think the term ML engineering, more or less, it evolved over the past couple of years. So the first question is, how do you define ML engineering, and how do you machine learning engineering, and how do you basically there's machine learning and then there's machine learning engineering. The question is, what is machine learning engineering? That's question number one. Question two, what are some best practices that you can recommend on how to do machine learning engineering in production and in AWS in general? Yeah, so two questions, so go for it.
I can try to answer it. So basically, I would say the difference between machine learning and machine learning engineering is that, well, since one of the challenges is that it's not somewhat transparent process. So like machine learning is about like how you can create a good model. But actually, like in reality, like when you have like existing business or you have some production, like the whole production process, like of getting like serving something to customer is like, it contains a lot of things which you also have to work on. Basically, you start with like business objectives, and you need to define like what metrics can you use and like what data can you use. After like you clear data, you label data, then you can basically create some type of model, and then you need to put it in production. And then in production, you will need to create pipeline to train the model. You regularly on new data, you will need to have a pipeline to make predictions. And I would say ML engineering is about like, usually it can capture like, depending on like how people define it, like either the whole thing or basically having this end-to-end pipeline that is about basically training the model and is about serving predictions. And you want it to be completely automatic. So you don't like, you want it to be independent, like, so you don't have to train it locally on your notebook or on your laptop, and then like upload your model to the cloud. So you want the whole thing to be completely automatic, and you want to have a way like for it to work without like your involvement. And I would say that in terms of what's best practices, like I think the main, like if I could make like the main best practice about what you can do in with ML engineering is to get as very early feedback from users. Basically, the whole infrastructure, everything is like, it results in one thing: get early feedback. Because I saw a lot of cases when people try to make the best model there is with dataset, but when they actually served the model like based on real data, it didn't show good results. Or maybe customers like changed like because, for example, when they ask customers what they want, it was like one answer, but when they actually showed some results, it was completely different thing. So I would say the whole thing is like we should be focused on getting early feedback, and that's why it's important to kind of like maybe don't like, it's critical to focus less on model performance and trying to get some early model predictions and just have something deployed in your infrastructure which you can basically give users to play with. And then you can kind of like get more data, because like once you get feedback from users, it acts like as a more data which you can use to improve the model and understand like what's the vector where you need to improve. Because sometimes maybe it's not critical that model doesn't perform as well, because maybe it's already better than nothing. But at the same time, it could be that, for example, model doesn't work as fast and it should work fast, and so on. And I would say on high level, like once you move to cloud, like I would say good practice is to try to kind of like switch from your experiment code, like which you run in Jupyter Notebook, to having like a separate Python script and Python package, which you can run like your experiment, and then containerize it in something like Docker image. So you can basically, because that's one of the additional challenges, that, for example, you run script on your computer, it produces one result. Your teammate runs it on his or her computer, it produces different result, and that's okay. That's kind of because like you have different versions of PyTorch, and it happens. But at some point you want to have like the same environment, and so that the results would be completely reproducible. And once you have like script which is inside Docker image and you have reproducible results, now you can actually put this Docker image in the cloud and run it on instances. So that, and now you can basically run training in cloud. So it's kind of like you can get closer and closer into putting the whole thing in the cloud and making it put everything in production.
Great, thank you for that, Rustem. Really great explanation. Cyrus, what's your take on it?
Yeah, maybe if you're talking about machine learning without engineer concept, it's much more like a researcher. Okay, in university, we are talking about how to just talk about how to create a model, how to make it more accurate or some. Yeah, it's not talking about something like Western talk about. It's very practical. You need to have the production pipeline. You need to think about how to make it in large scale, optimize it, migrate it. And for the engineer, with the engineer problem, you need to think about how to make it into the production pipeline. And that's the reason why it for the machine learning engineer, something like in the past, in the other domain, we talk about full stack. Okay, full stack developer. Actually, it's something similar to full stack developer, but maybe the full stack developer on web development. But machine learning engineer is full stack developer on machine learning. Is you need to know how infrastructure as code. Okay, you need to, but it is quite simplified for AWS. They have the SageMaker. You are doing infrastructure as code in SageMaker. You just use Python to create your load balancer, to create your cluster, you create your security group and something authentication. This is you are actually you as CK maker, you're just a data scientist, but you use a very simple, straightforward way. Just inside a Jupyter notebook, you create your infrastructure, and it is something that really nice for the data scientist point of view. In the past, data scientist is just able to build a model, and then they have to give the model to put into the server, and then other team need to help to make them to create a cluster and everything. They need to set it up, and another team really working together. But working together a lot of problem, and also this is you are able to do the full pipeline. If you can algae complete all the pipeline, it will be great. And it is quite different from the just machine learning and machine learning engineer. Engineer is something like a full stack developer. You're talking about you're able to build it from ground up. Everything you can do it, but this is not something very, very, very hard now. Is at least from AWS round, they try to make things simple. Just a line of Python code, you will get an API, the endpoint. But the endpoint behind the endpoint, you know, there is a lot of AWS setting already there. Auto scaling, load balancing, minimize the cost. They help us do a lot. Yeah.
Thank you for those answers, Cyrus and Rustem. So here's my question. Feel free to provide some context while you're answering this one. This one is going to be a really tricky question. So let's say that you were to build a startup. You have a really great idea or a set of ideas, and you want to build your data science and machine learning team. Yeah. So first, so feel free to answer this your way. But basically, the question is, do you hire a data scientist and a machine learning engineer, or do you hire just a data scientist first, and then, or do you hire a machine learning engineer first, or what's your preferred combination, especially when starting a startup, dealing with machine learning requirements in the first 3 to 6 months, and how would that change over the span of 1 year to 2 years? So how would the dynamics work? How would recruitment work? Let's say that you were to start your own like machine learning powered startup, and which one goes first? Yeah, or do you hire a developer first, build a website, collect some data? Yeah, so feel free to add some context when answering this question.
I can start answering the question. So I think it
Absolutely.
like
it's what okay. Yeah, it is quite similar.
Okay.
But in the past, we are always talking data scientists a few years ago, but now more people will change ourselves from data scientists to machine learning engineer or machine learning engineer. I think data scientists and machine learning engineer not they have something very common. Okay, they are both of them is doing model and it is maybe just the something like a terms changes, but they do something very similar. And but with the terms of engineer, I will say that it is something like that. You need a data scientist actually.
Is it me or Cyrus? Is it kind of laggy? Or Rustem?
Yeah, I think he froze.
Yeah. Oh yeah. So maybe Cyrus got disconnected. Yeah, we can continue with what Cyrus was talking about when he. Oh, there you go. There's Cyrus. Oh, here you go. Please continue, Cyrus. You're on mute.
Okay. Yes. Fine. Yeah. It's depend on your company business. As if you have some tasks, it's more on data analytic. But to be honest, not every company is looking for machine learning engineer. Especially for the business. The business, well, they look for the people to help them to analyze the data and then just build some model to disability detection, but they also want the people.
Yeah, I think maybe Cyrus got disconnected again.
Yeah, it seems this way.
Yeah, I thought I got disconnected. All right, so let's wait for Cyrus for 15 seconds, and then worst case, you can have Rustem tell us what his take on it. All right. Yeah. Cyrus, you there? Yeah. So let's have Rustem talk about his answers first. Yeah.
Okay. So I would say it's heavily depends on customer expectations within certain industry. Basically, for example, in self-driving car industry, you want your model to perform extremely well before it can work in production. There are some industries where you don't have to have like perfect model results. And my personal perspective, usually the main challenge for a lot of startups, and this is like fundamental challenge for a lot of startups, is that you want like to build a great model, you want to have data set, but you may be limited that like publicly available data sets are not full enough, and basically they don't capture enough cases. So you need to have some basically real data. And at the same time, to get some real data, you need to have like a model already working in production, and you need to have like already some customers to get this data. So you have this like chicken and egg problem that you cannot start one without another. And it's something which you have to develop in cycles. And I think you have to make something simple first and try to acquire customers with it. And then once you have customers, once you get more data, now you can improve the model. And basically, in this case, data becomes like basically one of the important resources which you want to acquire to make your model perform better. And that's for startup actually creates a competitive advantage. Like having some data set which other companies don't have is a big competitive advantage. Because basically, if something could be built using just like open source data set, then all companies are in the same position, and basically it would only depend like on how good your data scientists are. But I think like if you're going into some industry where there were no machine learning or deep learning before, then basically it's very hard to acquire data set. And that's why I think that like in this type of industries, it's very critical to start with, well, it's usually pretty good to start with machine learning engineers, because you want to have something in production to be able to sell to customers as early as possible, so you can get their data, and then you can basically iterate on it and make model perform better. And it will also give you an insight about what customers want, like where, for example, and what kind of products do they want, because like even the same core, like with the same machine learning stuff, you can build somewhat different products. So, and it has as much problem with like having like this product market fit and finding correct product for like your AI startup. But I would say at the same time, if your industry has very high standards in terms of quality, then you have to start with data scientists, because you would need to make a very complex models in this case.
Great, thank you, Rustem. All right, Cyrus, feel free to continue what you were talking about earlier. Yeah, go, Cyrus.
Is this another question or just continue the same?
So basically, you got disconnected while you were sharing something earlier. So if you have 2 to 3 minutes to talk about your previous statements, then go for it. But otherwise, we can proceed to the next question.
Okay, or maybe the next question or next topic.
Sure. Thank you for that. Okay, so there's something called model degradation in a production environment. So let's say that most of the resources that you'll find online is all about getting a machine learning model deployed into production. So usually the tutorial ends there, right? So probably 80 to 90% of the resources that you'll find online talks about cleaning your data, training your algorithm, having a model, deploying it to an inference endpoint, and then there you go. But sometimes a lot of people don't talk about, let's say, multi-model deployments, for example, or performing A/B tests, or even replacing your model in production. So my question is, what's your take on model deployments? Let's say, especially after you've trained your model, what would be your advice or suggestions or tips when dealing with models in production, especially when you start to realize that it's starting to have weird results, especially when it has been deployed for about, let's say, 1 month or 2 months already. And then at the start, it's working well. The first 2 weeks or 3 weeks, it's behaving well. And then after 2 months or 3 months, you'll start to check, do I need to update this model? How do we take care of these things? Yeah, so feel free to share it from your experience, or maybe share some tips and advice on why this happens and so on. Yeah, so go for it. Who wants to go first?
I can answer this. I can cover these questions. So basically, there is fundamental limitation of machine learning approach is that, like, if we speak about supervised learning, so that model only knows what it has seen before. So if you like process data which is completely outside of model pattern, then you may get like weird answers. And usually the best way like to monitor, like, there are a couple of patterns which allow monitoring that. Basically, first you want to monitor your data and always like know like whether like what's, for example, what's some distribution within your training data set and how it's different from your real production data which you get into your model. And usually it's a good thing to have this monitor for all incoming data. It does so basically to understand, like, did something change? For example, maybe images, like, for example, you make some production environment for the images and suddenly like there is a lighting issue and now your model doesn't perform that well. So you would want to be able to catch, like, for example, there is a difference in terms of brightness on new images. And that would give you insight that dataset changed. And because incoming dataset changed, your model doesn't perform as well. So another thing which could, like, which usually, like, once you detect that there is a change in dataset and if it's not the same, then you can retrain your model. You can either retrain it manually, but in both cases, whether you do it automatically or manually, there is a certain difference compared to software engineering. With software engineering, you develop new feature, you just deploy it in production, and you know that it should work well. You will probably use something like canary deployment to make sure that it doesn't break your production, but that's it. With production machine learning, I would say you are not 100% sure that your new model will perform better than old model. You kind of want it to be like that, but you cannot be 100% sure. So that's why usually you have to do something like A/B testing when you deploy a new model. And for example, part of your traffic goes through old model, part of your traffic goes through new model, and then you can compare the results. And once you see that model new model performs better, then you can switch the whole traffic to a new model. But basically, that's I would say the complex part is that you always want to update your model, but at the same time, you always want your new model to perform better than the old one.
Oh, thank you for that, Rustem. Cyrus, what's your take on it?
Yes, it's quite similar concept. Yeah, it is just something similar to migration to new system. No one knows, not just for machine learning. Any new system, you need to have a dark launch or just some proportion of testing. But how about the feedback? Yeah, for some of the error case, you don't know. It's the users need to tell you. Once the customer or user don't tell you, you don't know it's a problem. That's a case.
Yeah. So, okay. So we're at the 1 hour and 20-minute mark. So we'll probably wrap it up with the last 3 questions, and then we'll select some questions from the audience members. So they have some chat messages in Q&A, but we'll start first with some of the things that most of us would probably want to know. So let's talk about common misconceptions and mistakes in machine learning. So basically, a lot of, let's say, young professionals or enthusiasts want to learn a lot about machine learning, and they get to start reading some articles, or they try to take on some training. But then it's quite different when you're in the field and when you are about to take on a real project or a number of projects. So what are some common misconceptions and mistakes in machine learning that you would like to talk about? And why do we need to be aware of these misconceptions? And so who wants to go first on taking on this question?
Maybe just a few points. So I sometimes talking with different kind of, maybe some business guy or maybe some student or something like that. Everyone say that you deep learning, you deep learning, and it's not necessary, to be honest, unless your data is highly complicated or just not easy to understand, or complicated data, you deep learning. But for the very simple data, like from the data set from Excel, from database, it is something you can a lot of option. You may think about using export track, put a decision tree, maybe just some of the problem you even though you use a classical principal component analysis and then extract the information to visualize it. This is good enough, but not everything deep learning. Yeah, this is some misclassification recent year. Everyone come to here say, oh, I need to start with deep learning, but not every problem is necessary to do the deep learning to handle it. You don't have a lot of data, and also you don't have a very complicated data. It is not necessary to do the deep learning, as there's no difference at the end. But the problem is that once you are talking about you need to explain your model or some more information to your management or to the customer. They will ask you the data information, something like that. From deep learning, you are unable to answer it. You just something in, something out. Not every project you are suitable to use deep learning. If your customer will tend to ask you the reason and what happened, maybe there's some more data analytic point of view, you need to support your model. In deep learning, you're unable to explain it. You just know a very complicated equation inside. You just trust me, and not all of the customer will accept this answer. Yeah, this is the experience. You knew that, and they prefer you do the simple regression or just decision tree. They love decision tree, to be honest. They see the tree. Okay, very easy to explain to them, and that's the first point I think is for machine learning, not just deep learning. Okay, we are talking machine learning. Machine learning can do a lot of problem, but for deep learning, it's just a certain domain for very complicated problem. And also, if you want to try to build something on using machine learning or AI, first try is to use build a managed service to do it first. If not working, some customization on the AI service. You just feed the data there, the recognition, customer labeling. Try them, it saves your time. And once it's not working, try to download some pre-built model and see if you can train on top of it. Don't train it from ground up. It takes you a lot of time, and the performance you never know is good or not. Okay, yeah, that's some of my advice on model. Yeah. Okay.
Great, thank you for that, Cyrus. What's your take on it, Rustem?
Yeah, I totally agree with Cyrus. Like, if something could be solved without deep learning, it's probably better if it will be solved without deep learning. Basically, because one of the challenges with deep learning is that you have to supply a lot of data, and this data has to be like very high quality. And that's one of the challenges, is that, like, on one hand, you don't need to have like a lot of background in deep learning to start with it. You can use some existing model architectures, and you can even use some pre-trained models which you can fine tune. So you don't have to spend as much resources training model from scratch. So that's like two things which heavily lowers the bar for entry, and like you don't have to have as much deep learning experience on one hand. So it's, I would say, one thing is that you can actually start early, but at the same time, like another misconception is that you can do it with any data. And I think like one thing which you learn when you work more and more with deep learning models is that you have to supply, even if you fine tune, you have to supply like somewhat large amount of data, and it has to be very clearly labeled. Because, for example, any mistake in labeling like could make model perform a lot worse, because basically it always considers labeled data to be perfect, and basically it will try to learn it like, and it can fail if it's not labeled properly. And I think that the paradox of deep learning is that you spend a lot more, like when people think like what like people do when they organize deep learning train deep learning model, is that you spend like half of the time training model, but I think like in reality you spend maybe 10%, because 90% of the time you spend preparing data, labeling data, making sure that basically you have good enough data set, and only after that you can actually make a good enough model. But at the same time, model itself, like you can do something very simple which could work pretty well, and you can iterate on top of it. And I would say second misconception is that I would say it's mostly connected with deep learning models, is that you have to use GPU for inference. So usually you have to use GPU for training deep learning model, because it just takes a lot of resources for like back propagation step. But inference, actually, it's something which can be run on both CPU and GPU. And I can give you an example, something like Inception V3 model for image classification. On GPU, let's say P2X large, it would take 50 milliseconds. On CPU, which would be like C5 dot large, it would take 400 milliseconds. So on one hand, it's 10 times slower. On another hand, basically C5 large is a lot cheaper than P2X large, and it's a lot more scalable. Or you can, for example, use Lambda, and with Lambda, it would be something like 500 milliseconds. So basically, and it will not only, it will be slower, but CPU is more scalable, and since it's cheaper, the cost on inference will be lower. And it's something which you have to keep in mind, and it's like, it's sometimes a decision which you have to make, like whether you want to use CPU or GPU for inference. And usually the best way is like you try to deploy your inference or like prediction API on different types of machines, and you understand like what's your requirements. Do you have to serve it like in real time, and that's why you have to serve it like in a very fast way, or you have to have like the cheapest inference because you need to compute like thousands of them in parallel. So I would say that's the second one.
Great, thank you for that. So the last question, or potentially the second to the last question, is let's talk about future trends. Yeah, so what's new in 2020 and what's probably new in 2021. So let's talk about the future trends and what you think would be the next thing in the machine learning industry, or maybe in the world. Yeah, so go for it. So share some examples and new things that we have learned this past couple of months. Yeah, go for it.
I think the most exciting announcement of this year is the quantum computer in the cloud. Yeah, the Amazon bucket, and to be honest, if it is able to move to production, it will change it well. As it is very, you can say that it's another way to compute something. It's not just to 0 and 1. 0 or 1 is become, you can carry something 0 and 1 together to all of the bit in parallel. It will be a very powerful way to, it's something like a massive search for the solution. okay, you're searching, machine learning, something like searching, everything is searching, is to optimize your answer. And in CPU, you are just by sequence. In GPU, you're layer, but in later in the quantum, it will like parallel well, and everything go in parallel, highly parallel to resolve the problem. In the future is I think the machine learning, once the quantum computer is stable and the number of bit of quantum computer is high enough, it will solve a lot of very powerful machine learning problem, AI problem, with this kind of computer. But need to have some time. I think at least the number of bit of the quantum bit will be more, and now at this moment I think 6 or 5 bit in general. But once it's the number of bits is more, and now it will be have some production activity, especially in machine learning. Yeah, this is one of the things that's very exciting in the future, I think. And yeah, and also I guess in the future we are a lot of AI service. We don't need to build a lot of models, and maybe build model as a service later. You just give the data to the system, and the system builds everything automatically. Yeah. Okay.
Okay, thank you for that. How about you, Rustem?
Yeah, so I would add that like one of the trends, it kind of exists already, but I think it will gain a lot of traction in future is auto ML and auto DL. Well, not auto DL yet, but auto ML basically where, because there are limited amount of machine learning models, and now there are high level algorithms which try different machine learning models on data, and basically they try to find the best model with the best parameters automatically. So I don't think it replaces data scientist's job. It just like more like helps with trying different ideas and run them in parallel. But there is a certain trend that basically once you have prepared data set, currently I think it's mostly with machine learning, but basically once you have prepared data set, you can run some, it could be either like AutoML within cloud infrastructure, I think SageMaker Pilot, and I think Google Cloud also has this kind of feature, but also there are I think a number of AutoML frameworks which you can just run by itself. And I think there will be more and more AutoML frameworks which you can basically run in your data, and it will basically find the best model for you, and then it will train this model for you. And then on the output, you will know what's basically the best architecture for this specific data set. And possibly the same, like in future, could be applied to deep learning as well. Basically, once you have some some algorithm or some model which will find the best model architecture for your data. So I think that's will really improve or perform, like it will make it easier to find good performing models for a lot of complex problems.
Great, thank you very much for that. So this is the last question. What would be the tips for beginners and intermediate users? So basically, we'll end this session with you guys sharing probably 2 or 3 sentences regarding like tips on how to get started. Basically, you guys are the inspiration for different people, given that you guys are us. We are machine learning heroes, and a lot of enthusiasts and young professionals who definitely want to contribute more in the world of machine learning and basically be a machine learning hero probably in the future, right? So what would be your tips for beginners and intermediate users? So maybe 2 to 3 sentences would do the trick, and then we'll be good for this this session.
Okay. First of all, you can add the machine learning or AI power, use the mixture of the high level managed service API to create something on top of AI. You want to have your application or your project with AI, not mean you need to build a model immediately. You can make use of the high level service. For example, you want to build something on chatbot, you want to have some intelligence on the sentiment analysis. You don't need to build model. You just try to check with check with the high level API from different car vendor to see what existing API you can use is to add the machine learning power or AI into your project or new project. You just use it now, and then you need to learn, and you need to take maybe you need to take some basic machine learning concept. You need to know it. You can't just I don't think you just directly go to screen mechanic and do everything. You need to study some basic. You don't need to be an expert, but you have to have some basic background when you want to building the machine learning model. Yeah, okay. You need to learn something first. Yeah, I don't think you can know nothing to start, but you need to learn something and then try to. For example, you need to know the indicator, the metric for your machine learning model. You need to know the idea, the meaning of that. You can't just put the data there and then you put any data there, you will have something come out. Okay, always have something come out, but how good is this? You need to know. Yeah.
Great, thank you for that, Cyrus. Go, Rustem.
I would say like just two things. First is that it's always better if you have some project which you're passionate about to start with, basically, so you can basically have some data set and have some insight into like what you want to do. Like, because basically it definitely helps with learning when you have some idea about some project, data set, or problem which you want to solve. And if you don't, like, you can get a very good data set from something like Kaggle, which has a lot of data sets, and if it has something which you want to solve because you're passionate about it, and I think it could help with learning. And I would say second thing, which is more like an engineering thing, like if you want to deploy something in production, there is a way, like with AWS, it could be like using something like serverless, like AWS Lambda with PyTorch or TensorFlow to deploy your model, or like machine learning model, like LightGBM or XGBoost, could be very cheap, because basically AWS Lambda is part of free tier. So you don't pay up to a certain number of invocations per month. And it's something which you can easily deploy. And basically now you can write in your CV that you deployed AWS, you deployed your model to production environment on AWS.
Okay, thank you for the amazing session, guys. Thank you for that, Rustem, and thank you for the amazing session, guys. We'll definitely invite you in like the future Machine Learning to Zero events. Yeah, because this set of events are technically for you guys, for us, for the Machine Learning Heroes. So from the title itself, Machine Learning Zero to Hero, and it's led by Machine Learning Heroes.